Hello, and welcome to Mr. Ambrose's video on Voodoo Integration, or what's otherwise known as in the mathematical realm as integration by parts. This is another method of integration that you can add to your toolbox. Currently, you know how to find general antiderivatives and also know the method of integration by substitution. This is just another method that we have to help integrate. So to help introduce this particular method of integration, the example that you see on the screen says to integrate the integral of x times e to the x dx. Now you may consider that, well, obviously there's no general antiderivative just for that as is, so you may consider perhaps a substitution. The perhaps logical substitution would be that you would perhaps be equal to x, since we kind of see x inside of the e to the x function there. So if we go this route, then calculating the derivative for that equation for u and solving for du, we would get that du is equal to dx. And then if we start to make our substitutions, we would have the integral of x e to the u as a substitute u in for the x, and then du, substitute du in for dx. At this moment in time, we don't have everything in terms of u here, so we can't really integrate as is. So you may say, well, we could perhaps substitute u in for x, because that is what we're doing with our substitution here. And although that may be true, as I've had a little difficulty here writing with this pen, when we made that other substitution for u and for x, we're kind of stuck once again, because if you really look at what we have, and perhaps with what we start off with, right, these are really the same integral. So although we made a substitution and now everything's in terms of u, we haven't advanced ourselves too much, and we have to try something else. And that's where this Voodoo integration will come into play. So the integration by substitution that you know of technically is the reverse of the chain rule. And if you look at what we have in this original problem, what we really have here is x times e to the x. The Voodoo integration, or the integration by parts, is really the reverse of the product rule. So, or at least that's how I'll derive it. So the basic idea is that we're going to want to be able to somehow be able to come up with a way to perhaps integrate two functions like this here, f of x and g of x, being multiplied together, and be able to come up with what the antiderivative of that will be. So to help with this, we'll go and perhaps review again the product rule for derivatives. And I'm going to use the functions f of x, but big G of x to reproduce my product rule. And you'll perhaps see why I'm going to do that in a little while. The one thing I'm going to say, though, is that if you notice, I'm using big G of x versus little g of x. So I'm going to define the derivative of g of x to be little g of x, which is common notation when we consider perhaps the antiderivative of a particular function. We use the big letter, in this case big G, to represent the antiderivative of little g of x. Okay, so reproducing my product rule, the derivative of f of x times g of x, we all know, is the first function times the derivative of the second, so that'll be g prime of x, and then we do a little switcheroo, and now we have g of x times the derivative of the first function, call that f prime of x. And then now, in the first expression here, we have f of x times g prime of x, but again, g prime of x, I denote it to be equal to g of x. So I'm just going to rewrite that as f of x times little g of x plus, again, we have still big G of x times f prime of x. Right. And now it's at this time that we're kind of ready to perhaps try to work in reverse. Because remember, integration, I said, is the bizarre differentiation. We're always working backwards. And in my answer here, this f of x times little g of x, well, that's what we're trying to find the antiderivative to. And so I'm now going to work off of what I have here, work backwards to help solve for an expression that gives us the antiderivative rule for f of x times g of x. Okay, so now we're going to integrate this expression that we have for the derivative of the product of f of x times g of x. Hopefully you will agree that if we integrate this left-hand side of our equation, what we'll be left with will be just f of x times big G of x. Because, again, integration is just the reverse process of differentiation, which is what's happening on the left-hand side. So that the integration should undo this derivative part on the left side and leave us with this product of two functions. On the right-hand side of our equation, we'll have the integral of the sum of two terms. But hopefully you'll be okay if I were to take the first term and just have an integral for that, and then sum up the integral of the second term, as that's another one of the properties that we saw when we integrate the sum of two terms. Now, it's in, again, this left-hand side here with this integral of f of x g of x, that is what we're really trying to solve for. So if I just do basic algebra to solve for that integral, I'll have that the integral of f of x times g of x, that integral should equal f of x times big G of x minus the integral of g of x times f prime of x. And this now is the basic formula that we use when we want to perform the Voodoo integration by parts. But it's a little bit messy, it's a little bit cumbersome, and not the one that you will typically see in a math textbook. So, looking at the original integral, the initial substitutions that we usually make, and you'll see in the formula, is that I'm going to let that equal to f of x, and then everything else in that original integral, I'm going to set that equal to dv. So dv will equal g of x times dx. Then, if I take this equation for u and I derive both sides, and then solve for du, I will get that du is equal to f prime of x dx. And then my dv equation, if I actually integrate both sides, well, I'll get the antiderivative of dv is just v, and the antiderivative of g of x, we know, is equal to big G of x, because that's exactly how I set things up. And with these four terms, I can now use them to substitute into this formula that we derived to get the formula you'll probably want to use and memorize. So starting off, we'll have the integral of f of x, which is equivalent to u, times g of x dx, which is just equal to dv. And that'll equal, on the other side of the equation, I have f of x, which is equivalent to u, times big G of x, which is equal to v, minus the integral of big G of x, which is equal to v, times f prime of x dx, which is equal to du. And this is the formula you'll see in your textbook, and usually in any other math textbook. And it's this integral, especially on the other side of the equation, where I get my Voodoo terminology from. That's the Voodoo integral. Now, you may wonder, well, how are we going to use this formula to help perform integration by parts? Well, there are certain steps you want to apply to help apply this method of integration. The first step is to identify the u. And to help with that, the acronym LIATE, or Long Island 8, however you want to pronounce it, we use this acronym to help determine what's going to be U. Because in your integrand, you're probably going to have two functions being multiplied together. And when you look at those two functions, whichever of those two functions comes first in this acronym is the one that you want to use for your U. Once you've identified that U, you then want to mark off that everything else in your original integrand will be dV. After that, once we now know our U and dV, we want to calculate du by essentially deriving our expression that we have for U. And we want to integrate dV to get our V term. Once we now have these fourth expressions, U dV and du and V, which may seem like a lot, but you're going to take them and you're going to substitute them in to the formula we just derived. And once you've substituted everything into that formula, the last thing you want to do is you want to integrate the Voodoo integral. That's another reason why I refer to this method as Voodoo integration, because this is the integral on the right-hand side that you're really going to be working off of to help get your final answer. So again, that's a lot perhaps to take all in at once, but let's now try to perhaps apply that to the problem that we originally looked at, which was we had to integrate this x times e to the x dx integral. So again, the first thing you want to do when you're going to perform integration by parts, or this Voodoo integration, you want to identify your U. And this is going to be different than the way you chose U for integration by substitution. You want to use that acronym LIATE to help identify the U. The two functions that I see here in my integrand are x, which we refer to as an algebraic function, and e to the x, which we refer to as an exponential function. Since algebraic comes before exponential in the LIATE acronym, that's my U. And dV then is everything else that I have in my original integral. So dV will be equal to e to the x dx. Next, I want to derive my equation that I have for U, and the derivative of x we know is just 1, and then I'll write dx. Then I want to solve for what V is. I solve for V by integrating dV. So the antiderivative of e to the x I know is just e to the x. And so now I'm ready to make my substitutions into my Voodoo formula. The original integral, well, that's my u dv. I don't need to actually substitute that in. I know what those are now. That u dv, that integral of u dv, I know is equal to u times v, which in this problem would be x times e to the x. And then I got to subtract from that the integral of the Voodoo, which v is equal to e to the x. The do is just 1 dx, or just dx. Now that I've substituted everything into my Voodoo formula, the only thing left that I need to do here is I need to integrate this Voodoo integral. That's all that I have left to do. And the antiderivative of e to the x, well, we know that's e to the x. So the answer to this particular integral is that it is equal to x times e to the x minus e to the x, and then don't forget the plus c at the end. So this is the method of integration by parts, or Voodoo integration. I know it's a lot, so tomorrow when you come into class, we'll kind of jump into looking at examples of this nature and applying this method of integration. Hope you enjoyed this video, and I hope you have a great night. Take care, and see you tomorrow.